week 4, part 2, and we are calculating heat loss through a wall using the equation of Q equal A times U factor times delta T. So let's look at this example. We have a wall made out of brick with R value, so we have the R value. We added insulation with R value of 0.35. So we have the resistance of the wall and the resistance of the insulation. Okay? The temperature inside and outside, and we have the dimensions of the wall and the window with its R value. And we want the heat transfer through the entire wall. I don't know about you, but I'm kind of a visual person. I like to draw things so I can get a concept. So I'll draw this wall. 8 feet by 10 feet, and it has a window. The window is 4 by 4. Okay. So if I want the heat loss to the entire wall, including the window. So it's a wall in the room. I want the entire heat loss from that. There are 2 heat loss, one through the wall material and one through the window. You agree? So first of all, I'm going to go through the wall material. So I'll say Q wall. And as usual, always try to take steps and do it slowly. So what is the area of the wall? By 80 times U wall times delta T. So area of the wall equal what?
80.
8 by 10
12.
minus the window.
12.
12.
12?
Yeah.
Well, this, on your board is one thing, but on the
Yeah. So what are you doing on the
12
board,
feet
or-
is up
Okay,
there.
sorry. Okay? I'm going to subtract the window, which is 4 by 4. So I'm doing the wall by itself. And this question is going to be very common for the heat load balance exam. So this is the wall. So what is that going to be? 80. 80. Okay. What about you for the wall?
It'd be
1
0.2.
over R, right? What is the resistance of the wall?
Be
0.25, okay. But we added insulation, right?
Yeah.
What is the insulation? 0.35. This is our wall, this is our insulation. Anybody find this confusing? Resistance, we added the resistance of the wall plus the insulation. If there is no insulation, we'll take out our insulation. Question? So that will be 1 over 0.55 equals what?
4.35.
1.35. And that is my U, my area. What is my delta T? 70 minus
1 over 0.06.
Hold on, it's not.
4.35.
It's not.
4.35.
It's,
Huh?
it's 0.6, not 0.55. Yeah.
this.
So then it's 1.67.
Okay. So 70 minus 20, that's 50 degrees. Fair? Now I just substitute things in this equation. So Q wall equals area 80 feet times U factor 1.67 times 50. What do I get?
5,333.
5,333? Okay. BTU. Oh, am I done?
No, you gotta do the window, right?
Yeah. So I'm gonna do the window. Q window. I'll do it over here. If you think about it, it's kind of common sense, you know. Just don't ignore things. We're still gonna do the wall lights over the window. Under the window. So the window is going to be again. I'm gonna set the area times U times delta T. What is the area of the window? 16. U factor?
1 over 3.5.
1 over 3.5 times, what is the delta T? It's gonna be the same, right?
Mhm.
Switching the numbers. Oh, okay. I don't trust you guys. I got 228. On 6.
What is the .35?
That's the
Or the
our value of the window.
point?
3.5.
Oh, it says it right there, the
Yeah.
window, okay.
So Q entire wall. Q wall plus Q window. So we got 5, 3, 3, 3 plus 2, 2, 8, 26, equal 5, 5, 6, 1.6 BTU per hour. What do you think?
Um,
There is one.
yeah. I think I may have asked this last class, but where does the time fit into this equation? Like, how do we know if
This
it's
is per
a
hour.
function of time?
So the time is gonna be a part of the U factor. It's gonna be BTU per hour. That's the time factor.
That's what the,
Yeah.
so the U
It's
is
per hour.
incorporated into it?
Jason,
The heat transfer to the wall is not correct, that number.
numbers? Okay, let's switch it again.
Yeah, I'm saying for the wall, so for the whole wall.
80 times
The windows on the wall.
4.67 times 50.
Wait.
Yeah. Somebody's calculator is firing. We're happy?
Can you calculate through, like, in per hours?
Yeah, so now this is per hour, BTU per hour. So for 12 hours, we're gonna do 6908.6 times 12 hours. $82,000. So 82,000 BTUs going through 12 hours in that wall. So that's a lot. It's a small wall, it's a lot. What can I do to improve this? Add more insulation.
And
See your
better
window done, seal the window up.
Window's not that bad, to be honest. Look at the window, it's very
I
small.
was gonna say, the window sounds
So if
really
there's
good.
more than one window on the wall.
You can add, yeah, yeah. So if you notice, most of the heat loss are happening from the wall because my U factor for the wall is still 0.6, 1.67 is still high. So we need to add more insulation, find a better solution to that. Probably gonna add more, 0.35 is really small. They would put R16, look at this insulation. This is R4, which is 4 times this board.
So what
This
they
one,
add,
this
just
one
like,
is like 6, R6.
so was their insulation like Tyvek or something?
Huh?
I was gonna say, so is their insulation like Tyvek or something?
I don't know, something, probably it's only like, maybe air or foam or whatever. But this is really small, it's not realistic. What kind of insulation you can have? You can have some bone insulation, you can have some injected foam. There's a lot of ways you can do that. And it's better always to put the insulation when you start putting the wall. Retrofitting insulation is more costly and annoying, it's not as good. But if you go to an empty wall, you can also pump in foam into it. So I think I have this example worked out step by step. Let's see if I did it right. So you can look at the PowerPoint and follow the steps if you didn't miss out, if you missed out taking notes. Here are the numbers. Area of the wall. I subtracted the window, get 80. This is for the wall, 1 over R. I added those together, so I get 0.6, 1.66. Temperature inside and outside. So if you just go step by step, usually you don't go wrong and take your time. Step 3, we'll do the total number. I got the window, same thing that we did here, but now you have it step by step on the PowerPoint. And eventually you get 82,000 BTUs per hour. I mean, BTUs for 12 hours. This is per hour, and this is for 12 hours. What do you think? Seems like a lot of numbers, but it's all systematic process. Step by step, one by one, fill in the blanks. And you can use a calculator. You can, there's only one formula we need. It's Q or A times U times delta T. The formula for area is very simple. Usually they're rectangular. You're hardly ever going to find non-rectangular wall. So walls are usually rectangular. So, natural convection for doors and windows. They do. Any question about heat loss through a wall? We'll do a few examples. There is one in the homework. And there's a solved example in your book here. If you look in your book here, there's a complete house example. If you look at page 14, they give you a complete floor plan example step by step. If you follow that example, it should be really good reference. And you can keep it with you when you do your project.
Is this gonna be like what the test is like? They give us an
Yeah,
example and we
yeah.
have to figure it all
Yeah,
out?
they ask you specific things. They're not going to tell you everything. They give you a floor plan, and they ask you, what is the floor area? What is the ceiling area? What is the south wall area? And you're gonna go back to the floor plan and look at it and do the calculation. So it's good to go there with a scrap paper and pencil and do the math. Yeah. Yeah. Of course. Why not? So we'll go over again. It's there's homework about that. Windows and doors. So they do a lot of natural convection. They conduct a lot of heat and coldness in the winter. The leakage is minor compared to the transmission when it comes to doors and windows. Why is that? Leaks are minor because we can also always weather strip, and we also have a lot of molding. But a big problem is the transmission. And we say what are the two types of heat loss? Transmission through material and infiltration through cracks and holes. So the transmission is a bigger issue than the filtration. And we said doors are not as problematic as windows. Why?
Less window area.
Less moving parts.
You can insulate
And usually
doors.
they're better insulated.
Yeah.
And usually they don't use glass. If you use glass doors, probably it's gonna be like as bad as windows.
Yeah.
Yeah. So far, we covered building structure, heat loss calculation for a wall area calculation. And next week, or I'll start Friday. Actually, I wanna do more examples about wall, make sure that you guys got it. And let's do this one more practice problem. I'll give you 10 minutes, do it by yourself, then we'll do it together. How about that? So you can practice. Okay, shall we pause the video?